Alright, so here we are for a quick little video on including the confidence intervals of your regression, so that we're doing an 80% confidence interval. Again, I'm working with my natural log of sales. You're going to do your confidence interval based on your the regression that you think actually works best. So the basic equation you can get from here, and I have another view of it here. The standard forecast error is the standard error of the estimate times the square root of 1 plus 1 over n plus x minus x bar squared divided by our sum of x's squared, and the sum of our differences squared. And these sum of differences are going to be only over estimation period. As we move forward, this stays constant, and this one will basically just continually get larger and larger, which is why our forecast error increases over time. Our x minus xm, our x variable, is our counter as we go through here. And we want to subtract the average, so I could say it equals average, and then we would go from 0 through 18. Which is going to so 0 through 18, which will come out to 9 exactly. So what just to make it simple, I just locked in the B3 here, so it's B4 minus B13 $sign, or equivalently, I could, instead of using that, we can just look at the average, set it as F4. Either method, I mean, obviously we're just dealing with 9, so either way is appropriate, and drag that down. And then of course we can go ahead and drag it forward as well to include everything. Our forecast error then is going to be an application of our equation, so it's D36, which is the SSE of the regression, multiplied by the square root of 1 plus 1 over n. Actually, now that I look at it, this should be 19, because there's 19 observations. 0 through 18. Let me drag this one down. So it's the square root of 1 plus 1 over 19, 1 over n, plus G4, which is just our x minus xm, and we square that, and we divide that by the sum of squares, some square function for G4 through our G22, which is just the estimate period, end it with a parenthesis. In order to calculate our high limit and our low limit, we're going to need a t statistic, the student t. This is what's known as t inverse, so we're asking for a 20% probability, which is 10% on either tail, and then D37 is the degrees of freedom that we have. So in this case we have 19 observations minus the 1 for the average or the intercept and 1 for the coefficient, so 17 degrees of freedom. That gives us a student t of 1.333. To calculate the lower limit, we take our estimated value and subtract from that our t statistic and multiply that by our forecast error. And then our forecast error will change as we go down. We leave the same statistic on there at all times. And as you might guess, the high limit is just going to be our forecast plus the t multiplied by the standard error, the number of standard deviations away from the expected value. Now to add these to the plot, so we want to see a high and a low value associated with it. I can go ahead here to my design and my data. So I'm going to go ahead and just remove the lower limit here real quick. So my upper limit still sits, and I'm just going to add back, just to show you how to do it, our lower limit, our lower limit. And the x values that we're interested in here, that's the one around the axis, so we need to highlight our dates again. In other words, it's going to default to 1, 2, 3, 4, 5, which isn't going to show up on the plot. And then we're going to select our y values, which are the lower limit series that we've calculated. And that's going to add our low limit dots, and then we can play around by changing this, formatting the data series. Our marker should be no fill. Our marker options actually is just none, and then we want to line color. Let's pick our line style, which is just our nice dashed line, and then our line color. Solid line color, we want our blue again, and then we want to change our style to the dashed. So we now have our forecast through. Actually, we want to drag that one down towards the end. So we now have our high and low limits set up on our graph, as well as our standard or actual data points, and just a basic line fit associated with it. And that's the whole process. Again, for whatever model works best for you. And the next video that I'm going to do is going to be to show you how to download the sales data for the next 2 years, for the last 2 years that we have available, and then to plug those back in. It's a pretty short video, just to plug them back in. So we'll have observations for 2012 and 2013 to see how well our forecasts work against actual numbers. So that's part of your evaluation. You'll put those numbers in for the 4. Well, let's just say you put it in for 3: the linear, the quadratic, and the log transformation regressions, and see how well your prediction did against actual values for 2012 and 2013. All right, thank you very much.